My name is Phillipe Sayegh. I'm the Chief Adoption Officer for Versys. And what I'm going to talk to you about today is about cognitive computing and using next generation artificial intelligence. So the fuel here is the data, but the articulation is context. So we're a company founded in 2018 in Eindhoven. Eindhoven is our European headquarters. We're also based in Los Angeles, where the company was founded. We've developed a cognitive computing platform, which is called COSM. And we've based it, most interestingly, on a very new set of standards. So you will see a lot of innovations today, a lot of groups working on standardizing data. We worked on standardizing metadata, and more specifically, contextual metadata, to be able to govern the behavior of people, things, and processes in the real world. So we're a public company. We have contributed to the Open Day report that was mentioned earlier, sections 233 on hyperdimensional interoperability and 246 on executable policies for digital governance, if anybody's interested to look into the details there. So what we bring to the market, and I'm going to link that to the health sector in a bit, is we bring about new protocols that I'm going to be talking to you about. So a new grammar, and a new communication protocol to be able to explain the world to machines, to AIs, to robots in a way that humans comprehend it. A cognitive computing platform that allows to govern the behaviors of different edges in a scene. So think about a scene in a hospital, think about a scene on the street, etc. And then we have spatial applications that have been developed on COSM using the protocols as well. So what's new? Well, I think the yoga experience that Luke shared is an interesting take as opposed to the crane here. We operate in three-dimensional worlds. So we have a cognitive understanding of the world around us, which is multidimensional. We're using at least 5 senses to capture the world, and all the activities that are happening in the world today are tracked in columns and lines on screens. So there's a gap there that we think can be bridged by bringing compute and data into the world. So we call this the spatial web because it eliminates the boundaries between physical objects and digital content. And more interestingly, we're moving from a web of pages to a web of spaces, right? And I'm not talking about data spaces. I'm talking about multidimensional spaces. They can be 3D, 4D, 5D spaces. And I'm going to talk more about that later. So if you look at and this is, I'm just going to browse through the theory here for a bit, but we're in Web 2.0 today. So we're working on mobile applications and cloud, and everything is moving slowly to AR, VR, IoT, artificial intelligence and smart applications, and blockchain and edge. This is what we call the spatial web. The spatial web requires an augmented infrastructure, a new way of describing the world, to be able to compose with the new constraints brought about by the multidimensionality of where the computing is going. And just as a side note, when everybody talks about Web 3 or what's now called Web 5, cryptos, NFTs, and DLTs, we're on the data layer, which is on the blockchain edge, starting to dabble in smart apps, but we're not there yet. So why metadata? Well, for a very good reason. Generally speaking, common sense or common knowledge actually tends to say we have 5G and 6G networks that are exponential. Enterprise stack that we already know. We have new cool exponential technologies that are getting to fruition right now, robotics, AI, IoT. If we take these 3 components and we sandwich them together, we will get a compliant, secure, privacy-preserving infrastructure. The answer is unfortunately not that simple, because there are 3 components that we've identified that are absolutely key to be able to govern the behavior of people, things, and data for that matter in space. It's the management of identities, the management of activities, and the management of spaces and places. And this is what the new protocols bring about. It's how to describe who has the right to do what, where, when, and how, and why. For example, applied to data, we can decide that a surgeon in the oncology sector, in the oncology section of a hospital, can only access the oncology data of the patient in the same room where he is, for example. Right? When you're navigating a robot autonomously through a hospital, a robot needs to understand the configuration of the hospital, where the robot can move, where the robot cannot move, what are the different activities that he can operate. Can he just take the temperature? Can he bring food? Can he do something? right? So we need to be able to identify this in a standardized way across different edges and different systems. So we're talking here about metadata interoperability that feeds off data spaces. So the spatial web standards have been given to the world. They're now in the IEEE that deemed them as a public imperative. The applications for those standards are numerous. We're focusing right now as a company on supply chain mobility and smart cities, and we're moving slowly into health. And these standards basically are the following. Our anchor, instead of being a URL, which is www.philippe.com, is a spatial domain. So it's a geospatialized point in space with a volume around it. So a room in a hospital is a spatial domain. The bed inside the room is another spatial domain. The patient on the bed in that room is yet another spatial domain, et cetera, et cetera. HSML, which is the hyperspatial modeling language, describes the rules and the regulations of what you can do in that space. Can the patient lie on the bed? Can the doctor come into this room? Can this test be done in that specific room or not, etc. And then you have the hyperspatial transaction protocol, which is the smart contracting capability that I just described. And this is everything is stateful and adaptive to the change of context. So we have indoor spatial domains. I'm giving you here the example of a warehouse, but this could also be a hospital. And we have outdoor spatial domains that we can manage as well. And so the modeling language here, this metadata contextual modeling, basically describes who has the right to do what, where, when, why, and how. And I'm going to get into more concrete examples around that. So let's take a hospital robot. We're going to say that an identified robot by virtue of Health and Human Services within the domain is a USC medical center shall have the right to take blood pressure as represented by the medical procedure certificate. That's the credential. The robot is certified to perform various procedures. The action is to take blood pressure again on an identified human patient in the patient's room and nowhere else, in physical reality between this time and that time. And there are channels that we maintain as well. So if you're for example, I'm just going to keep on the hospital example. If you're the director of the hospital, you can see everything and all the activities and all the data of that hospital. But if you're the patient, you can only see the data that is relevant to you. And if you are the doctor managing a ward, you will have access to the files and the data to everybody in that ward. So the idea here is to be able to have a shared understanding. Let's take the hospital model of what's happening in the hospital, whether you're a person, whether you're a robot, whether you're an AI, or whether you're any kind of object. I'm taking drone here because we did manage projects where we were doing urgent deliveries for blood samples and organs. And so the idea is the following. You have the real world on the left-hand side, and then you have the modeling or a sum of digital twins or sum of data spaces or data sets around the specific world. And what we want to do is to sense the world, understand what's happening, model the use cases, plan them, simulate them, and then act upon them. And this is what we call the intelligence loop, and this is what the platform brings. It allows edges, so they can be AIs, they can be machines, they can be humans, to understand the world in a multidimensional way. And we can actually, what's also interesting is that we have identified a way using HSML to transcribe legal legislation and policies into machine executable code. So the robot that is roaming around your hospital, his behavior, his activity can be policy compliant with the government policies, with the hospital's policies, or with the ward's policies of that specific oncology section, for example. And so when we looked at the market, we have identified massive inefficiencies where we're talking specifically with hospitals, but not only, obviously, where there's lost inventory, time spent searching for equipment, supply chain savings from greater planning, analysis, control. And so there are smart hospital operations. This is what our technology allows us to do. We execute on simulated scenarios and operations. So we can do, for example, from an asset tracking perspective, real-time inventory management that are spatial, that allows us to understand where they are physically in a hospital, because we will be using the digital twin of the hospital. Bed management, we can do route optimization. If you're trying to find your way through a hospital, we did this in warehouses. We can very easily do those in hospitals as well. And spatial tasking, so basically robot cleaning, in-room delivery, ward planning, etc. In order to be able to do this, we've talked about earlier on about interoperability and standards. Every single edge or every single actor in a specific scene needs to understand that scene in the same way, in the same description. And the good news is we can start doing this now. We do not have to wait for everything to be standardized because we're working at the metadata level. So on the metadata level, we are going to decide which robot can do what, for example, in a hospital. And then we're going to model the hospital, model the robot, and model the different use cases, start simulating, and then executing on them. And allow basically to optimize the flow of people and processes and things in a hospital, in a ward, but we do this also in cities, to allow those flows to be autonomous, efficient, compliant, and secure. So this was a very quick snapshot. That's it for me. Thank you very much for your time, and I'm open to questions whenever you're ready.